Hello everyone. Today we are going to see the adapter pattern. Okay, so in the adapter pattern, what we do is our client has the requirement that it wants to call some API in certain fashion. So client will call the target API, which is a request API, and there are some existing classes that are there. So we want to call or we want to use those classes. So how do we do that or how do we implement it? By using adapter pattern. So we create an adapter class. Adapter class will implement provide that interface, okay, that the client needs. That is a request here in this case. But internally, this request will call a adaptee's specific request. So even though this doesn't provide the interface that client is looking for, internally the same class gets used. So that's why it is called as adapter pattern. So it is similar to the adapter that we use. So client has a request form of this rounded socket, but what we have installed in the system is not rounded, but it is a square. So what do we use? We use an adapter which converts this request into the appropriate form, right? So let's see that with the example. Let's say we have a class, a rectangle, okay, and this class has uh, a method draw, okay. Now this draw method is supposed to draw the rectangle. Now the class that we have, which is our legacy rectangle, okay. Now this class doesn't have, we can say it has x1, y1, x2, and y2. Okay, these are the rectangle top left and bottom right corners. And the method that it provides is not draw, but it has a method called as old draw. Okay, now we can say that cout slash n, um, yeah, old draw method. Okay. Now, what we want to provide client is this interface now, and this interface, this actual implementation class doesn't follow that interface, so we can't really use it. So what do we do here? We create a new class called as a rectangle adapter. This will derive itself from a rectangle, and it will derive from a legacy rectangle class. Okay. Now, what it does is simple. It will have its own constructor, right? X2 and int y2. Now this is simply going to call a legacy rectangle, and it is going to same x1, y1, x2, y2, right? So that will create this object, right? So definitely we need to have that constructor here, right? So I'm gonna simply copy that. Okay. So this is our legacy rectangle. Now this will get copied in the members. Okay, we assume that it's copying that. And now here we will have our virtual void draw method, which will say that legacy rectangle draw adapter. We can say adapter draw method gets called. Okay. And here we will call legacy rectangle old draw, right? So now this is the adapter class, which will provide the similar interface to the one that client expects, but internally it calls the legacy rectangle, right? And here now uh, we can say that a base, or we can create a rectangle base class, rectangle star base pointer is equal to new rectangle adapter, right? And this one will provide the rectangle endpoints, the corner endpoints, and when we call a draw method here, what will happen is basically this draw will call the draw of rectangle adapter, and that in turn will call the legacy rectangle old draw, this method, right? And old draw method drawing a rectangle with the required, you can, you can display all these values x1, y1, etc., etc. All right. So that will work fine. So when you run this, you'll see that adapter draw method gets called, this one, and then old draw method drawing the rectangle. All right. So this is how this adapter pattern is used, which makes use of the existing code with the new interface, right? So thanks for watching.